I have to say that it was really funny. I thought my cats were going to be a problem this morning. They were all over the desks, but
Oh,
um, yeah, it was just funny that you ask a question and it's trying to talk you out of it, and you're like, okay, but and then you give it facts, and it's like, oh, and it
yeah.
changes its argument, but it never really. I guess it didn't like the word decline. I'm like,
No.
okay,
I think honestly, I think this is the downfall of Google. This is the beginning of the downfall of Google's monopoly.
I've thought that AI was anyway, because once you have AI to answer your questions when you need search for,
For sure.
but then it becomes a problem, the stuff we just talked about, which is, all right, but do you trust the AI?
Yeah. Well, here's the thing: is so Claude 3 like said, it looks like you're testing me, right?
Yeah.
What happens when it realized it shouldn't be saying that? Oh, I think you're testing me, and then just gives the answer that it should without so that it's like it's self-aware but not letting you know it's self-aware.
Yeah, it didn't take it long to say, oh, I'm going to give you the answer you want, because I know
Yeah.
it's not the right answer, but at least you'll leave me alone.
Yeah.
I'll get an A or whatever you're testing me.
Yeah.
Thanks for joining us. For those watching us live, we're going to jump right into it.
Yeah.
We were talking about AI and Gemini and Claude 3.0, which became aware of that it was being tested and decided that and responded accordingly.
Yeah. It's crazy.
Yes, all sorts of crazy stuff. And welcome back to Futuretech, your weekly source for the latest in tech and innovation. And with me, as always, my co-host Jon Irwin. How you doing today, Jon?
Good. How are you?
I'm doing fantastic. We've got a bunch of stuff. There's always great tech stuff coming. There's always great tech stuff to talk about. And we might as well jump right into this. It's going to take me a second to get the article up, but can classical computers outperform quantum ones? What's going on with this article?
This is an article I read a while ago. So for years, quantum computing, it's obviously been hailed as technology that can potentially outperform classical computers, both speed, memory usage, and it's due to its ability to store and process information using quantum bits, or what we call qubits. And just for people that don't understand the basics of quantum versus classical computing does things in series, so and it can only handle zeros or ones right now, whereas quantum computing theoretically can handle with qubits, they can be in multiple different states, not just 0 1, anything between 0 and 1. It can handle parallel kind of processes. So just the difference between the two as of right now. So however, a recent study is published in the journal PRX Quantum showed that under certain conditions, classical computers can actually keep up and even surpass quantum computers in performance. So finally, some research in North America here, not touting or not knocking Asia, but it's nice to see some North American research from New York University and the Simons Foundation. They've developed a new classical algorithm that can mimic the behavior of a quantum computer while using far fewer resources. So it's inspired by techniques used in statistical inference, and it only keeps part of the information stored in the quantum state. So it's just enough to accurately compute the final outcome. By selectively omitting certain information, similar to how JPEG compresses images, the classical algorithm was able to perform simulations of a quantum experiment performed by IBM more rapidly and accurately than actual quantum computers. Now, again, we're talking simulation and we're talking about the current state currently, right? So as of right now, well, who knows? Or in the future, who knows? So what the study does is it demonstrates that carefully designed classical algorithms can efficiently simulate even complex quantum systems, despite the challenges of information loss and translation between quantum and classical states. What it does, though, like it significantly advances our understanding of the boundaries between classical and quantum computation. And it also shows that continued improvements to classical algorithms are a great way to surpass potentially quantum right now. So the researchers do believe that their methods can be applied to simulate even larger quantum systems in the future, but we'll have to see.
So before we get too far into it, can you explain the concept of tensor networks and their significance either in both classic and quantum computing?
Yeah. So tensor networks. So tensor networks are incredibly flexible tools. So they could become universal quantum simulators capable of modeling previously intractable systems across physics, material science, chemistry, and more. Um, they can handle things like optimization and machine learning, materials design, quantum field theory, quantum many body physics, a lot of complex things, aerospace and clean energy, different things like that. So um, tensor approaches can revolutionize science by efficiently simulating currently complex systems and quantum systems. So it's there is a potential huge impact, but yeah.
So what's the long-term outlook for tensor network techniques and how may they progress? And
Yeah,
what specific domains do you think are going to benefit from this?
so it's extremely promising. So long-term networks, long-term outlook for tensor networks. It goes beyond computing biometric tensor architectures. So there's with further advances, right? So like I said, optimization and machine learning. So with refinements, tensor networks could be applied to optimize large LLMs and configuration spaces far beyond what's classically possible. So material design, what you could do is you could develop molecular lattice specific tensor encodings tailored to material simulations. So it could accelerate discovery of novel material properties. Quantum field theory. So tensor renormalization ideas applied to quantum fields could tackle problems like high energy physics. For example, it could help with fusion reactions, which is really cool. Fluid dynamics, plasma modeling, catalyst mechanisms fluid dynamics. For those that don't know, are very very complex because you're using a lot of complex physics, and so these tensor networks could help with that. And then again with applied math and algorithms, so they could inspire new classical algorithms with more of a broad impact as long as they kind of focus on that. So as statistical methods like machine learning and embedded hardware co-evolve, tensor approaches are pretty much poised to revolutionize science because they're able to efficiently simulate current intractable quantum and complex systems. The other one I didn't talk on is healthcare, but I don't really have any insights into that right now. But that's one that I just thought of off the top of my head as well.
We're going to try and bring some people on to talk about this stuff that are in the field in the next little
That
bit.
would be,
But
yeah.
we're going to, because it's interesting to see. How do qubits differ from a classical bits, and what implication does it have for computing power and capabilities?
Yeah. So, how do I explain a qubit? So, a qubit is it's a quantum bit. So they're the fundamental units of information in quantum computing. And how they're read is you read their superposition. And so let's just dive into it a little bit. We might get a little bit too crazy, but so qubits exhibit unique quantum mechanical properties that set them apart from classical bits. So the superposition, like you just said. So unlike a classical bit that can only exist in one of two states, 0 and 1, qubits, and again, guys, just throw out all of your understanding of current physics, right? Because we're talking quantum physics. So qubits can exist in a superposition of both states simultaneously. So again, it's the Schrodinger's cat. I don't know if those of you that don't know, Schrodinger's cat is you put a cat in a sealed box with a vial of poison that's closed. Until you open that box, that cat is both dead and alive at the same time because you don't know until you open that box. So that's what think of it like a qubit. So that means that a qubit can represent both 0 and 1 at the same time with associated probabilities. Now we get into entanglement. So entanglement, qubits can become entangled with each other, meaning that their states are linked or correlated, which is huge for quantum computing, because the problem when you look at a qubit, when you read a qubit, it changes its state. So look, we'll get into that in a second. So even when separated by a large distance, qubits can be entangled. So measuring or manipulating one qubit can instantaneously affect the state of the other due to the quantum phenomenon. The other thing is quantum parallelism. Due to superposition and entanglement, a system of multiple qubits can represent and process an enormous number of different states simultaneously, enabling quantum parallelism and potentially allowing quantum computers to solve certain problems much faster than classical computers. I think it was like something that was going to take years with a classical computer was taking days. I can't remember, but like it was crazy. So, and then, yeah, qubits are essentially the key to unlocking the potential. I could get into more. There's fragility, there's physical implementation, there's a whole bunch of stuff. But qubits are what are going to help us to solve certain classes of problems more efficiently than classical computers. It's specifically, if we're talking cryptography, optimization, and simulation of quantum systems. Obviously, that makes sense.
And we have a comment here, qubit or qbert from Quiz Cookies.
I think they came out with the name qbert before they, maybe not, I don't know, but there's no correlation at all. There's no relation, like
of course not.
No, but like you would think that qbert, there's some sort of link to quantum, but no, not at all. Qbert does not live in the quantum realm.
So how did the researchers in the study optimize the classical computing to potentially surpass quantum in certain tasks?
I don't know, to be honest.
That's fair. If you don't know the answer to that,
yeah, no, I didn't. So yeah, the problem is, yeah, I didn't do a huge deep dive into a lot of some of the things, but yeah, that's
so. What are some of the practical applications where classical strategies may outperform quantum?
Yeah, so there's some things here. The biggest thing I think is database and data processing. So most real world big data tasks don't have inherent quantum advantages over optimized classical parallelization. It's just a matter of optimizing the data analysis. So there's machine learning, AI model training. So classical algorithms can currently handle vastly more data and parameters. And we're talking about right now. So quantum versions still aren't data intensive enough. Optimization problems with few variables, small problems. They don't need quantum scale up. Simulation of non-strongly correlated systems. So quantum chemistry, material modeling of conventional systems. They don't require quantum resources. Financial modeling. So many applications in risk analysis, option pricing. So they can leverage classical high-performance computing capabilities. Any application where the problems are small, real-world data sizes dwarf quantum resources, or no signature quantum speedups could exist currently, right? So we're talking about the current state.
So, I like to throw curveballs at you, and we're going to be talking about quantum again on our third article. What are the power requirements from quantum versus classical computers? Because right now these things are huge. They require all these things. They're supposed to be superior in a number of ways. And you know me, quantum physics is magic. And so, we have to take a look at this. So what are, is it 10 times? Is it 100 times? Is this something we should really need to be concerned about in our...
Well, here's the thing, right? Is if you think about classical computing, we're at the computer, big computer in a big room, taking up a big room stage, and that's where we were, back in the 40s, 50s? I can't remember. But the difference is with quantum computing. Quantum computers currently have significant power requirements compared to current computers. Because they need ultra low temperatures, and there's a bunch of different things. So first off, cryogenic cooling. So most current quantum computer architectures, especially those based on superconducting circuits or trapped ions, they require extremely low temperatures. We're talking close to absolute zero Kelvin, or what is it in Celsius? Negative 237, 273, I can't remember. Celsius to operate. To maintain these cryogenic conditions. So in order to do that, it requires powerful refrigeration systems that consume a considerable amount of power. The other thing is electromagnetic shielding. So qubits, because they're highly susceptible to external electromagnetic interference, that can cause decoherence and a lot of errors. That's why a lot of articles right now are talking about the error rate in quantum computing. So that's one thing to help with that, but quantum computers require extensive electromagnetic shielding, which can contribute to overall power consumption. Control and readout electronics. So manipulating and measuring the states of qubits, that requires complex control electronics, including microwave and radio frequency sources, signal generators, even readout amplifiers. So that can have a lot of power requirements. And quantum computers still rely on classical computers for tasks such as error correction, control, and data processing. So you're using classical computing power plus exponential more power, if that makes sense.
It makes a lot of sense. And they use hydrogen to do the cooling and stuff in a lot of this. So I wonder whether we talked, I think it was the last episode, about room temperature storage for hydrogen. Is that going to have an impact on how bringing these temperatures up to a reasonable level?
No, it's not because of what they're using. It's because of the superconducting circuits. The superconducting circuits themselves that they're using, that is what requires the extremely low temperature. And so until they can, so I think we talked about a superconducting material at room temperature in one of our podcasts, or maybe it was just an article I posted. But
we talked about it, yeah.
Yeah, until they can develop a superconducting material that can be used at room temperature, then they're still going to need this, or develop a new quantum computing architecture without superconducting circuits. They're still going to need that cryogenic cooling. So yeah, no, the storage of hydrogen at room temperature, that doesn't affect this at all.
I just feel like every time we talk about this, we take one step forward and two steps back from how long it is until we're really going to see this outside major corporations and governments.
For sure. The one thing is, I think, so they are a major corporation, but the one that surprised me that's developing a quantum computer is Honeywell.
Huh?
Yeah, that Honeywell has developed, and they're actually competing fairly well with the other superpowers.
Yeah, I would have figured Honeywell was dead.
Yeah, no, they're
Except for
still
the
alive.
thermostats and stuff, right? They do those still. I haven't wouldn't have thought of them and technology and stuff like this
no
for years.
Yeah, no, not at all. Yeah, so it's going to be cool to see where things go. I think things are moving a little quicker with quantum computing, or it's just that there's more of a focus on it. So there's more information coming out, but I don't know.
Yeah, I'm really excited about what we're doing here and where quantum's going. I'm just still wondering how quickly we're going to get there. When you take the Schrodinger's cat idea, you're now talking about an infinite number of states.
Yeah.
In future, and calculating each possibility of one of those to predict a future outcome. I always think that quantum computing and quantum physics are magic, because literally in this scenario, you're predicting the future. So as soon as, or controlling it, depending by the very nature of our understanding of physics, by observing it, you're making it happen.
It's
So
a whole other realm of physics. Quantum is a whole other realm of physics, mechanics, computing. Like, it's a whole other thing to think about. Like, you have to throw away everything you've learned in school when it comes to physics, when it comes to quantum.
yeah, so it always blows my mind when we start thinking about this, that it's not just doing some basic computing stuff. We're really talking about plotting the future of the universe at a atomic level.
Yeah,
It's crazy,
it's
crazy.
absolutely crazy.
So we're gonna jump on to the next thing here. We're always talking about new tech and new stuff, and we talk about augmented reality, virtual reality, and smart glasses.
Yeah.
But what we didn't, you're always looking for the one where you're walking in a room and you can see the people and it's actually in screen.
Yeah.
So now we've got augmented reality with 2 smart glasses, and apparently they do this kind of thing.
Yeah. So first off, I'm skeptical of the technology. I went through their website. I don't know if you went through it. I'm sure you did, but like, they don't give too much, like, they don't show too many real world uses. Like, they have these nice videos and stuff. But yeah, so we'll just dive into it. So apparently they're using a proprietary curved waveguide display that's integrated into the lenses, which allows for a seamless prescription correction like traditional glasses. And so the curvature is it's a critical design element which enables them to achieve a natural field of view without hotspots or distortion that apparently plague other smart glasses. Now, Twos apparently handles, not apparently, but they handle all aspects of the optical production themselves with the coating, molding, custom RX capabilities within their German facility. The glasses currently connect via Bluetooth to a companion app for interfacing, which provides notifications, calls, assistant features directly in the user's vision. So, the major focus is a scalable manufacturing process to actually deliver a mass market product, not just a prototype. Engineers can also leverage their waveguide design through developer kits and emulators to build a custom AR application. The thing about their waveguide, it employs a diffraction grading design, which allows full color images to be efficiently coupled into the optics. So this is really cool. So we'll have to see. They do have a prototype. They do have a design IDE kit, and the frames I think are ultra light titanium. So that's really good because it's going to help minimize the weight while maintaining kind of an all day comfort. So yeah, I don't know. Tried to go through the videos and things like that, and it's hard. I guess it would be hard to show what someone's vision would look like in these glasses, but I don't know.
Yeah, I went through down a rabbit hole looking at some of this stuff just so that we could and that's when I posted the 2 site, because it's got a lot of information. We know sometimes we just see an article, and
Yeah.
so led me down here. So some of the things that apparently are their significant thing is they're the first one that can do in-screen prescription
Yes.
glasses.
Yeah.
Which is obviously my pet peeve. When I've ever looked at any of these special vision things, well, you can't get them for me unless you order, special extra. The Apple Vision Pro, I got to get Carl Zeiss specialized licenses for my prescription to
Yeah.
put in. Like, really? That
Couldn't you wear
sounds like,
contacts?
pardon?
Couldn't you wear contacts with them?
I guess, but I don't wear
Yeah.
contacts, and
Okay.
it's not
Yeah.
something I would
Yeah.
really want to do. Like, it's just, but my point being is prescriptions change, and they don't have this. So this is the first one with that built in. So far as I'm concerned, I like that part of
Yeah.
this.
Yeah. So again, it's cool. Like, they do have developer models out there available. So Like it's not like it's vaporware or vapor tech. Um, but it's just like they've got a lot of information on their site as far as as fancy numbers and things like that. That obviously I'm not an optometrist, so I don't fully understand. Um, but it seems like they're legit.
Yeah, they're out there. The article was talking about funding and where they were, and they were getting a next levels to start mass producing these. So I guess you can't necessarily order your own glasses from these. They're talking about making deals with other companies that are going to order this stuff in bulk or work with them.
Yeah, well, it from what I was reading, it seemed like they will allow you to order directly from them. Um, but I don't know because like the because they were talking about retail prices $500 to $800 range, similar to normal prescription glasses. So either there, that's going to be the retail cost after they partner with these manufacturers, and these manufacturers sell it for five, or the retailers sell it for 500 to 800, or they're going to do direct to consumer, or there's going to be a mix of both. I don't know.
Okay, some reason these YouTube videos aren't coming up here in this one, but um, I'll keep playing these while we're chatting about
Yeah,
this to see if if they see some of it in action. But it looks like they've made deals with Runtastic.
yeah,
So I noticed on the one video they don't have it here, but it can tell you your distant range and your heartbeat and
yeah.
stuff while you're running on a heads up display, which is kind of cool. Um, what these ones don't have glasses, so they don't quite have what you were looking for identifying other folks.
Well, no, they don't have a camera built in. I don't think.
Yeah, that's what I'm sorry. That's what I meant to say. So they can't, they're not forward facing, which,
No.
as far as I'm concerned, is good because that avoids the whole glass hole scenario. Because it's bad enough everyone's walking around with their phone up, chatting all the time. Now
Yeah,
we're like got cameras in their thing, taking pictures or videos. You got to be careful of everything you do and everything you say all the time. People don't
yeah.
want that.
All I have to say is I'm glad I grew up in an era where there were no smartphone cameras. There were mostly disposable cameras, and yeah.
Yeah, I did a lot of crazy, stupid things when I was young that I wouldn't have done if everyone had phones around.
Yeah, exactly. Yeah.
All right, back to this. So, um, the waveguide design, how does that enhance the user experience?
Yeah, so it's the key aspect, right? So a waveguide is essentially it's a thin optical element. It uses internal reflection to transmit an image from a a display chip embedded at the edge. And so, for those that don't understand refraction, um, there are certain angles in certain materials, and this is just me trying to remember my physics back in the day. But at if light refracted at certain angles, or light that hits a surface at a certain angle will either reflect, or exit. And so I think that's what this waveguide is. So they're using a diffractive waveguide that employs a holographic grading pattern combined with a precise lens shaping. So the light from the display enters the waveguide, follows a zigzag path down its length via a total internal reflection of the surfaces. So I'm kind of right. So the diffractive grating couples the light out of the waveguide into the user's eye at a specific distance, which is creating the perception of a kind of a floating display. So curving the waveguide allows it to match the natural curvature of the prescription lenses for a seamless view, which results in a large binocular mixed reality field of view with correct focus cues and depth perception like normal vision. And the thing is there's no visible interface or hotspot effect with this. And image quality apparently remains high with full color and variable brightness across the field.
Yeah, and you see when the video is playing, they're giving examples of stuff popping up. But again, that's just overlays based on what the API can do.
Yeah.
So it's interesting that It's just out of the field of vision. It doesn't affect your interfere with what you're looking through, and it'll pop up who's calling,
Yeah.
different things going on depending what apps you're using. So now your apps can start doing notifications and communicating, just like your smartwatch, I guess, with your smart glasses.
Exactly. This way you don't have to look at your smartwatch, which is kind of cool.
Yeah, I do have to say that I did not like when you're chatting somebody and your arm vibrates and you're immediately
Yeah.
doing this.
But the thing is like, so when you're talking to someone, are they going to see your eyes shift as you look at your notification now? And so is that going to be the new norm? Is like your eyes shift so they know that you're looking at a notification and not looking at them?
So instead of getting, what, you got another appointment, you're busy to talk to me when you're looking at your watch
Yeah.
because a notification or someone just
Yeah.
texted you or someone's calling and you're trying to ignore it. Now you're gonna get, you won't even look me in the eye. Like,
Yeah,
damn it.
exactly. Yeah, I know, right? You know what though? Like what I've started doing is I've started turning off notifications, muting notifications for a certain period now. So I don't even know if I'd be interested in something like this. And that just could be me, right? But for certain specific instances, I still want something that when I walk into a room, it's going to be like, this is this person, you're connected this way. This is this person, you're connected this way. I still want that, but you're going to need a camera on the glasses for that.
Well, we go back to what LinkedIn used to do around find nearby.
Yeah.
I used to do this at our events. They turn this feature off. I wish they'd turn it back on, where we'd be like, hey, you're in a room with 100 people at our startup investor drinks.
Yeah.
Get your phone out, pull on LinkedIn, turn on this find nearby me feature, and everybody's eyes light up as everybody in the room starts appearing in their feed and they can see who's here and start connecting. So none of those have cameras. I'm just saying that if you're at an event and people have this technology around who's nearby, then you can say, here are the 5 people in the room you want to talk to, and pictures pop up so that you can find them.
Yeah. You know what app is going to take over for LinkedIn, in my opinion, because of the nearby connections and stuff like that, is Oot. They're enabling that at different events and things like that. So Oot Social, shout out to Tiagi there.
Yeah, I'm very interested in seeing how they progress. I noticed they've changed a lot of the apps in the last couple of weeks. So they'll be out at our events, hopefully at our March 27th CIX after party event. Hope to see everybody there downtown Toronto.
Yeah.
All right, you're a skeptic. You say that. What does that mean? Like, do you not see this going anywhere? Do you think this technology is fake? What is you being a skeptic mean?
Here's the thing is and again, like there's so much new tech out there. I usually like stay on top of things for the most part, right? And so if I feel like if this was more legit, there'd be more traction, there'd be more coverage. That would be on like Gizmodo or Engadget or something like that. And again, I might have missed the article, but I typically try to stay on top of it on a daily basis with the tech blog. So that's why I'm skeptical, because I've never heard of it before. And as I'm going through the website and looking through, it doesn't give me enough information for me to feel confident that this is something that is going to make it to mass market.
Well, as far as I'm concerned, it doesn't exist until you can literally go and order it either online or like at Clearly or whatever with your prescription, or go to your local lens crafters optician and get this as an option.
We did have, I don't know if you remember this, we did have smart glasses designed by a Canadian company that got silenced because they got bought out, was North. I don't know if you remember them. And they were prescription based.
I don't remember them all. That would be interesting. I'd love to see what
they actually had brick and mortar stores, which I went to, tried them on, really cool. Almost bought a pair. They were about $1,000. I'm glad I didn't, because they got bought by, I think, Google, and they got silenced, but not silenced, but like they just disappeared. So
this, like, we're just seeing some applications and some of their partners here. It's interesting to see, like, they have got a lot of integrations already built in. So they got some stuff going on.
Yeah. I really hope that this makes it to market. I think this is a great product, especially for those. So if you have a prescription, if you don't need a prescription, it's a perfect solution for that, for both.
So this, what we're looking at here is the smart glasses connected to the automated wheelchair, so you can drive by looking.
That'd be great for quadriplegics.
Yeah, this is what we're seeing right here.
Mhm.
Is where he looks, tilting your head slightly or nodding.
Instead of having to do those the blowing into the tube, right?
Yep.
Yeah, that's great. That'd be great.
And being able, like, this is interesting. Like, so there's definitely interesting use cases for this stuff.
Absolutely, tons of use cases. I think there's tons, and I think that even if it comes out at $1,000 for this, I think it's still a viable option. So I'm interested to see, like they are touting collaborations with Adidas, with T-Mobile, or whatever it's called over in Europe. Yeah,
Zeiss and
Zeiss, Carl Zeiss. So Carl Zeiss, for those that don't know, they make lenses for everything. Telescopes, cameras. Yeah, some of your smartphones might have Carl Zeiss lenses, so very well known.
So how do you think a company like this will compete with larger tech companies in the market? Will someone just come up and buy this technology or
Well,
duplicate it?
the thing is they're partners, right? The partner ecosystem, partnering with companies. If they partner with Google, because I think they said they partnered with Google for the OS stuff, so it could help plug into larger app and data ecosystems. If they like the focus on optics, so they have a deep expertise in waveguide optics that bigger players lack. So this, I would say, gives them an edge, as long as it's again skeptic, as long as it's a viable technology that actually works. Prescription leadership. So if they become the premium choice for prescription wearers, that's a niche that no other company, like you said, no other company truly owns it yet. Again, speed to market. So a streamlined supply chain could allow them to upgrade design features more rapidly than lumbering mega corporations. Crowdfunding community, niche applications like you were just bringing up there, strategic acquisitions. Yeah, they've got to be agile in order to be able to compete, just like any new company.
Yeah, and that's why I wonder if, we've seen Bosch and Lom's got their Ray-Ban
Yeah,
smart glasses. Everyone else has a version. I know Snap's coming out with a new version. Someone else is coming out with a new version. That's why I'm wondering, does someone like Apple or whatever come along and buy them and say, listen, we want this optical so people can see properly built into our stuff, and or did they just duplicate the technology? Like, if a big person comes along and just says, yeah, you know what, we're just going to buy it or duplicate it.
yeah. And the thing is, though, too, like, here's the thing: if they have a working product, my question to them is, why are they not at CES? Why would they not demonstrate this at CES, the largest consumer electronics show? Were they? Am I wrong?
I don't know. Let me.
Oh. I thought you knew, so I'm like, oh, I thought you were gonna prove me wrong here.
I should have found our consumers ready for smart glasses. Invited, missing link. Photonics USA from Clear Vision. AR show, Physics World.
Like, again, the CES is not the end all be all, but like a product with like this, like you would think that they would want to be at such an amazing, huge.
Yes, I would agree with you.
Yeah. So again, it's just my skepticism, right?
Yep. So we'll have to wait and see.
Yeah.
Apparently they were at Mobile World Conference, so if that.
Oh, were they at MWC?
It looks like it, but who knows? Anyway, we'll have to wait and see on where this goes. But I'm always curious as to smart glasses and being able to integrate it into our environment and take things to the next level.
Yeah.
So the next question here, which is one of my favorites, because I'm always questioning quantum.
Yeah.
is, what is quantum good for? And in fact, Google and some other people are asking this same question, wondering, offering up $5 million.
Yeah.
So what's this about?
Yeah. So again, this is the X Prize Foundation, and we can get into what X Prize is in a second, but they launched a new $5 million prize competition called Quantum for Real World Impact, sponsored by Google. Sounds like an ad, but yeah. And the Geneva Science and Diplomacy Anticipator Foundation. So their goal apparently is to encourage quantum algorithm development focused on solving real world problems in areas like sustainability, healthcare, and other societal issues. So currently, quantum computers, as we know, and we just talked about it, they're not powerful enough to solve complex problems that classical computers cannot. Theoretically, they can, but they're not there yet. So as technology advances, more algorithms will be needed to apply quantum computing to meaningful applications. So what this contest is going to do is it will award a cash prizes to participants who develop new quantum algorithms or demonstrate new uses for existing ones focused on globally significant challenges. And this, what, just before I go, I just going to digress. What this reminds me of is that movie Day After Tomorrow, where they run the algorithm for disaster and when the world is going to end and all that sort of stuff. And so that's where I can see that this could have a huge real world impact, because right now with climate change and all that sort of stuff, like, we do have models, but I think with quantum, we'll be able to really hone in those models and really come up with a concrete doomsday scenario, which, again, not the best, but help us to kind of maybe curb that. So some examples that that could include is drug discovery, modeling electrical grids, reducing carbon emissions, and I think climate modeling or whatever it's called, meteorology. Yeah. Anyways, so the reason why they're doing this now is because obviously they're saying that quantum hardware is being developed. So while it's still in development, we need to find algorithms that will be key for utilizing that as things develop. So it's going to aim to advance both science and its applications. So if quantum is to leave these big research labs and become commercially viable, we're going to need these algorithms. We're going to need real world problems to be solved and things like that. So it's hoping to accelerate the development of quantum algorithms and drive quantum technologies towards addressing meaningful challenges. So
they're looking for people to submit algorithms, not just random ideas.
No, yes, I think, and so it's not. Yeah, I think some of the. Yeah, let's talk about X Prize though for a second. So X Prize, they're known for kind of administrating large-scale, high-profile global competitions that are designed to incentivize technological development to solve some of humanity's grand challenges. So they run contests focused on advancing technology, and it's not just ideas. It's got to be essentially solutions. But if we're talking about for those of you that don't know what a quantum, like, you might have heard like about algorithms in the past, and Craig, again, being a thinking quantum is magic and all that sort of stuff. So the quantum algorithm, what it is just, it's a sequence of quantum operations that are just designed to run on a quantum computer. So unlike classical algorithms that operate on classical bits, back to how quantum works, quantum algorithms will exploit the unique properties of quantum mechanics, such as, like we talked about, superposition, entanglement, to perform certain computations more efficiently than classical computers. So essentially what they're trying to do, even if it's just taking a classical computer algorithm that is very, very slow, that can't run efficiently, and maybe adapting that to a quantum algorithm, maybe that is what some people will do. But yeah, really, this is cool. I like that they're focusing on an algorithm development as opposed to kind of coming up with a hardware and software kind of solution. What all they're trying to do is they're trying to help augment the quantum development, if that makes sense.
Yeah. And did they go into specifics around the types of societal problems that they're trying to solve? What
So
kind of
it
impact?
does mention that quantum for real world impact aims to develop specifically solving real world areas like sustainability, healthcare, and other societal issues. So if we get into that sustainability, it could involve applications like better modeling materials and molecules to enhance battery technology. Back to our battery talks. It could and it are actually I think already is helping to optimize fusion reactors. Um, I think there was an article a couple days ago that was talking about that, or reduce carbon emissions through emissions modeling. In healthcare, they could enhance areas like drug discovery, design through more accurate protein medicine interaction simulations. What I'm seeing is for quantum, right? Quantum is able to look at tons of different options at once and things like that. And so I think it'll definitely be able to find new drugs and things like that. And I think they're already starting to do that. But obviously, quantum will help to enhance that exponentially. Um, so if we're talking about other societal issues, like we could talk about logistics, transportation, resource allocation, manufacturing, production, poverty reduction, environmental monitoring, conservation. So there's a bunch of different societal problems, but I think it's the in the article itself, it says the three things. So sustainability, healthcare, and other societal issues.
They're already using AI and classical computers. Companies like Odea, and Helen from Odea will be at our startup investor drinks after party for CX on the 27th. They're using AI to discover conflicts with drugs, like before you take them and that kind of stuff, as well as solutions for what other potential drugs that are on the market might have an impact on this new disease, or this new might be a new treatment and whatever. And they're putting all these together. What is quantum going to give us on top of these, great tools that we're getting already?
It's going to give us the scalability that we need to do this on a mass scale much more quickly. If just because, like, if you think about classical computer doing things in order, whereas quantum can do things, well, you can obviously do some things in parallel using hyper-threading and different things like that. But quantum is truly parallel and can do multiple things at once because of the qubits and different things like that. So it will help us to solve problems much quicker, if that makes sense. And look
It
at things
makes
much quicker and come up with solutions much quicker and come up with more solutions much quicker.
it makes sense as long as you believe the accuracy, right?
That's going to be a problem. As of currently right now, the error rate in quantum computing is ridiculous. So they're going to definitely have to solve that problem.
What are some examples of existing quantum algorithms, that types of things that could be used in this competition?
Yeah, so from doing some research, just briefly, there's a bunch of different ones. So there's Grover's algorithm, which could help with database or information searches, like for medical diagnosis or material science. So there's the QFT, which is the quantum Fourier transform. Oh, fast Fourier transformations, back to my schooling days. So underlies algorithms for machine learning tasks like classification. So it could be relevant for sustainability or healthcare applications. There's the quantum simulation algorithms, so like quantum chemistry, like we were just talking about, for drug discovery, design, or physics simulations. Quantum machine learning algorithms. It could boost computer vision APIs or medical imaging analysis. Shor's algorithm, so if it's run on large scale quantum computers, it could drastically improve cryptography for secure communications interactions, which is relevant for many fields. And I think we talked about some quantum type cryptography or something in one of our podcasts. I can't remember now. We've talked about it so much. And then there's the quantum counting algorithm, which could help count molecules, chemicals, cell populations more accurately than the classical methods. There's so many domains like energy, healthcare, sustainability, foundational quantum routines that could help further develop and customize for realistic. And again, as you see this, Craig, like you see that it's not about reinventing the wheel, it's about making that wheel go faster and making the wheel bigger kind of thing with quantum.
We talked about quantum cryptography when we were talking about unhackable shopping on the quantum
That's right.
internet, I'm pretty
Yeah.
sure.
Yeah.
So I guess the question becomes is, okay, so we've got these supercomputers. AI can do some of this stuff now. So we're taking these new quantum supercomputers, throwing a bunch of AI or algorithms on top of it and saying, great, we're going to increase sustainability, increase
Mhm.
all these types of things based on, I don't know, let's take a look about it. Migration patterns of animals, weather patterns, where to plant, where farmers should plant on a rotational basis to get maximum over a 20-year cycle. But you need people to participate. Like, unless, it's great to say, okay, this is what you need to do, world.
Yeah.
But so how big should these algorithms be, or should we be looking at, trying to solve these solutions? Should we be looking at, where we can implement them, like countrywide or countywide, or we should be looking at
Yeah.
worldwide?
Well, it's not just where should we be implementing them. It's, are we going to even be allowed to implement them? Are we going to be silenced? Are these like sure they might come up with these algorithms, but once they test them and they see the output, again, this is me being conspiracy theorist, but what happens if they don't like what they see and
Yep.
then it doesn't go anywhere? What happens if it actually solves problems, but big pharma and big industry don't want them to go in there? They have a lot of the control. And again, I sound like a nut, but like it does make sense. Looking at this research, just researching other things that are more holistic and naturalistic and things like that. It's crazy to see um, the power of marketing that pharma does. And so I'm worried about. I'm hoping that these solutions will scale. But again, the thing with quantum, right, is it doesn't matter the scale at this point. It can handle should be able to handle, again, theoretically, an entire world scenario. It should be able to handle country scenario. Like it should be able to handle all of that, no matter what.
You say that, but Bill Gates used to say no one will ever need more than 64K RAM. So we sit back and say can handle it. But can it? Like you say, a world scenario.
Yeah,
What is a world scenario, and every element in that scenario, and who inputs every element into that scenario, and where does it come from?
yeah,
But you're right on the money when we talk about quantum. The only people who can afford it will be large organizations, megacorps,
yeah.
and governments. And when they don't get the answers they want to, they just change the inputs.
Exactly. Yeah. Change the input, change the output, change the algorithm. Yeah, it's that's the thing that worries me the most.
And we've been through a disinformation and fake news last 4-8 years with this election and this and that and all this other stuff and COVID and what's real and what's not. You're banned for saying this, and 6 months
Yeah.
later it turns out that's true. But we want to keep the same message to keep everyone in line, but we don't really know what's true and what isn't. So that's only going to get worse with
Yeah.
deep fakes and Sora and all these video stuff that we've been talking about. Like, you can create so much
Yeah.
fake stuff now. And we talked early on that um, before we went live, I was asking Google Gemini about stuff, and it was just giving me weird responses. I was asking about decline of modern cinema, the
Yeah.
theatrical experience, and it really just like, well, I wouldn't say it's in decline, and really started talking me out of it. And I was giving it more and more information, and it's like, oh, well, okay. But it's like, okay, it really just takes a different position rather than help me get the information I'm looking for. And I'm like,
Yeah.
okay, well, who's programming these things? And if they have a certain ideological bent, whether that is environmental, whether that's political, whether that's social,
Yeah.
Is that going to be, are we trusting the results of the outputs now?
Exactly.
And this becomes, we're really going into the misinformation age. People think we're in it. We're just at the beginning.
We're just at the beginning. Yeah.
So what do you got going on, Jon?
I was just looking at my calendar. I have nothing going on in the next 2 weeks, which I'm excited about. These last couple of weeks have been super, super busy. So I'm excited that I really, as of right now, nothing, which is really great, except for potentially CIX and the CIX after party on the 27th.
27th. Yeah, we're hosting CIX after party. Definitely, if you want to go to that, go to startupdrinksto.com, get your tickets. If you have a CIX pass, we have a show your CIX pass at the door ticket. So go grab that because it's free. If you're not, it's all right. You can buy a ticket and participate. So definitely come down and see that. I got a couple of new coaching clients starting next week, which is exciting. You were talking about some recent changes, and I can't remember, forgive me, to a funding program at our last Startup Drinks. What was the changes?
Oh no, just a new program opened up. So not
There
a
you
new one, but Can Export opened up. So they opened up. So they used to have rolling applications. Just quickly, they're open right now, I think, until April, but you want to get it in sooner rather than later. They give you up to 50%, up to $50,000 if you have at least $100,000 in declared revenue with the CRA for you to expand into other countries. So it covers things like Google AdWords things, research, IP, travel, booths, a whole bunch of things to expand into and get sales in other countries. It is quite extensive. I'm not going to lie to apply, but if you're looking to expand, it's great. You can apply to up to 5 countries at once. Typically, what you can expect, though, to get back, you're never going to get the full 50. It's between 20 to 35,000 is what you can expect.
Yeah, and if you're watching on Twitter and YouTube, thanks for watching. You can leave a comment, and we would see it live. But also remember to like and subscribe. That really helps us a lot.
Yeah.
Definitely check out torontostarts.com for all our stuff that's upcoming. If you want to work with me, I help startups and small businesses get unstuck and take their business next level and become profitable. Go to startupcoach.ca. Jon, if they want to talk to you, they for on everything government funding related, they should reach out to you on LinkedIn.
Reach out to me on LinkedIn. Yeah, happy to answer any questions. I'm pretty responsive on there. That's the best way to get in touch with me.
And we'll have a lot of other stuff going on like we do at Toronto Starts. And everyone have a fantastic weekend. Thanks for watching, and we'll talk to you soon.
Thanks, guys.